I'm super excited to have Vilva here. We've been in touch for a while, and he's going to be talking about optimistic UI with GraphQL and I guess like JavaScript, maybe TypeScript. We'll see. So Vilva, I guess that you can go and share your screen and start your talk.
Thanks a lot for the intro, Carlos. Let me share my entire desktop. Maybe. Is my screen visible, Carlos? Like, is everything fine?
Yes, you are good to go, and all the screen, audio, video, everything is yours.
Oh, thanks a lot. Yeah. First of all, thanks for having me here to be speaking, and congratulations. We are still waiting for your new job update, actually. And
Thanks, Vilva.
It was an amazing talk, David. Like, you just have set the bar so high that I'm already nervous. Thanks for the beautiful talk.
Thank you very much.
Let's start. By the way, today the topic will be like I explained. It's more about optimistic UI. Why we need optimistic UI? What are the real life examples that are already existing, and how how a optimistic UI can impact your UI. That's what we are going to talk about today. MVP program. It's for anybody who starts in this Corona lockdown times. People gets ideas to get MVPs soon. We have a program for them. Cool. Let's begin. What is optimistic UI? Optimistic UI is not a very big, it's a fancy term, but it's a simple front-end development paradigm. That's how we call it. And what it does is, the UI just be optimist. So it assumes that always for every action, it's going to be positive response, and it already updates the UI accordingly. So the client updating UI optimistically, assuming request is successful, is the main definition of optimistic UI. How it works? When the real operation is happening, actually, it already switches to the final state, so the user doesn't feel like the real operation is still in progress. Does it mean like are we lying to the user? No, definitely not. We are not lying to the user, but we are predicting, because most of the times we believe in our code, we believe in our APIs, so we say 100 times, but 100%. But no, most of the times our operations are going to be successful. And so we already predict it to be successful and start updating the UI for the user. In other words, if you have to say what is optimistic UI, optimistic UI is a UI which knows how to manage time well, unlike me. Like I'm very bad in time management. So why do we need optimistic UI? First thing is, it gives an impression to the user, whoever using it, like your app is super fast. The user don't have to wait and wait for any operation or get blocked on the screen and just wait for the operation to get completed. It just makes your app feel faster. And the major advantage is on slow devices. It gives us seamless operation. Like for instance, mobile devices, even though we are in 2020, we still have Corona and all the stuff, but still mobile devices are slow at areas. It's not uniform, it's not reliable. And in devices like that, the speed, the UX is so important to have a user getting stayed. Or he just switches tabs and goes to the next. To give a good experience to the user, mainly on slow devices, optimistic UI is the best option, I'd say. The next thing is, it doesn't break users' flow. There's a reason why I highlighted flow in caps. It has nothing to do with the static type checking flow. There is a psychological concept called flow. Users, or generally humans, when they get involved in work, they get into a state called flow, where you would have often wondered as developers. I assume most of the people are developers who are attending. You would have often wondered sometimes when you're working deeply or very interestingly in a topic or in a subject, you will feel like you have reduced the number of blinks, or you haven't even blinked your eyes. That is because you are in the flow state. This psychological flow state gets a user completely involved in anything he's doing. And the optimistic UA helps the user stay or continue in the flow state itself. It doesn't break the flow for the user. And next thing is, it streamlines the experience. Like, say, in olden days, we used to see the entire screen blocking loaders, right? Like, the whole screen will be blocked with a semi-transparent black tint background, and the loader will be spinning in the middle, and we have to wait slowly, seeing when the loader will get over. So, optimistic UA avoids all this stuff. These are the major advantages of optimistic UA. Okay, optimistic UA looks so cool so far. So does it mean like you can implement it everywhere? You can implement it however you want? No. There are few things which you should consider before using optimistic UA. You should first find where to use it. That is what I mean by 1 second can be forward sometimes. Like for few operations, the user is okay to wait. There we don't have to use optimistic UA. But there are few operations where the user expects an instant feedback, and that's where we should decide whether we should use optimistic UA or not, based on your line of business, based on your users and other stuff. Next important thing is response to control activation. So what is this? This is again a psychological term. Response to control activation is nothing but when you do a control activation. This control activation is nothing but activating one of your controls. That can be your mouse click, that can be your keyboard key press, that can be your joysticks, light pen, whatever it may be. When a user activates a control, he expects a response in 100 to 200 milliseconds. So if you see, the blink of the eyes is like 100 milliseconds. So we never feel 100 milliseconds as a time at all. We feel if something gets to us back within 100 to 200 milliseconds, say 150 milliseconds, we feel it's already instant, because we are used to our blink of our eyes. We never know we are blinking actually. So that's the time which is very optimal or very good for a user to get response after a control is activated. Hence, you should decide if you are going to use optimistic UA, you should respond within this time. This is a very good time for using optimistic UA. And the most important thing, API success rates. Mostly, we use optimistic UA not for something which happens in the front end or in the client alone. We use optimistic UA in cases where the client has to interact with the backend or with the server, right? That's when like it takes a lot of time. We don't know how long it will take. So we just shows the user like already it's done, it's successful and all the stuff. But if your API fails, it's going to be so dirty. Like the user got a awesome feeling. He feels like in heaven when he is using your app, and suddenly, bong, an error message comes saying like your API failed. That's going to be having a negative effect on optimistic UA. Hence, your API success rate should be more than 97%. Only then go for optimistic UA, or just follow the traditional ways where you use loaders and all the other stuff. And like I explained flow in the previous slide, the ideal time within which we should respond to the user, otherwise exceeding the time which the user's flow gets break, is 2 seconds. Believe me, get it right, it's just 2 seconds. If you get distracted for 2 seconds, your flow gets broken. That's the reason most of our developers like prefer big earphones, wearing it overhead and like not focusing on the outer world and just getting core into the code. Reason is this is the reason. Like it's a psychological reason, and this flow gets broken even if they are distracted for 2 seconds. That is why, like when I code, I mostly code in the nights. I don't get any distractions. These are the metrics we should have in mind. So if you're even going to do optimistic UA, of course, every time you can't give a 2 seconds response, but we'll see how to handle that. But it's so optimal if you can give a response in 2 seconds. That too, depending on your line of business, it can be so critical as well. These are the key metrics we should have in mind when we are implementing optimistic UA. These are the main numbers. Now let's see what are the different types of optimistic UIs with real world examples. First thing is subtle UI. Subtle UI is nothing but it gives us a positive feeling. This optimistic UI is so optimistic, like you do something, immediately it gives you a response. It makes you feel happy. But if it fails, we there's no way to know if it failed or if it's still in progress. It doesn't tell us at all. It just says you did an operation, assume it's successful, just go and do your other business. Don't worry about this. That is subtle UI. And subtle UI with progress is subtle UI again. If it fails, it doesn't show you any error messages, but it still can show you a progress. Like say you make a API call and it's in progress. It shows still it's in progress, but if it fails or if it errors, it doesn't throw an obvious message on your face. That is subtle UI with progress. Next is UI with progress and actions. What this does, when you make a request, it updates your optimistic UI. Like it updates your UI optimistically, assuming it's going to be successful. But at the same time, it gives a clear indication that it's still in progress. And if at all it fails, it gives you a list of actions. This is one type of optimistic UI. But it still doesn't throw a very obvious error on your face. The last one is subtle UI with error. When you don't feel it as an optimistic UI at all, you just keep on doing your stuff. But suddenly when the optimistic UI breaks at some point, it throws an error on your face. I'm sure Google Docs doesn't do it anymore. That's why I'm not able to get a screenshot of it. I'll show examples for other types in the next slides. But Google Docs used to have a feature like where you keep on typing, but if you're not connected to internet, it will try to sync it for some time, but after some time it tells you on the face. It gives you a pop-up. It says like you are not connected to the internet, so your changes cannot be synced or saved. This type of error is like normally the optimistic UI is subtle. It doesn't throw anything or it doesn't tell anything on the face. But when it faces an error, it just throws it on the face. And remaining three things, we'll see it with examples. Subtle UI. Twitter is a beautiful example of subtle UI. If you see here, I have liked the post, and if you see in my network tabs, the events are still pending. Like they have just started. They haven't even given a response yet. But already the UI has turned into a liked state. The post has already been liked by me. This is subtle UI because I like this. Say I after liking this post, I just scrolled down and I just moved to other post. And say if this APIs, which is supposed to increment the likes, got failed, then it's going to be a problem because Twitter doesn't tell you that this particular post is still not liked by you. It doesn't throw any error. It doesn't show any progress. It just fails silently. Because Twitter considers like a person not liking a post is not a very big deal. Like they are just fine with it. But most cases they are so reliable or confident on their APIs, it's always successful. But there are a few cases in my past as well where I had to use my mobile network. I'll be traveling. I like a post, and after some time, if I see it will not be liked at all. So that's something live example or real world example of subtle UI. This Facebook Messenger is a beautiful example for subtle UI with progress. You type in a message in Facebook Messenger, send it, you get a feeling like the message is already sent. Like it's so optimistic, right? But it tells you in a very subtle way that it's still in progress. If you see here in the first screenshot, below the text message, you can see an empty round. Like there's a circle, but there's nothing inside. If it fails, it turns into something else. If it's successful, it turns into a tick mark. If it's seen, it turns into a blue tick mark. So this is a beautiful example of subtle UI with progress. Yeah, it gave us a good feeling. We are happy that our message has already been sent. But at the same time, it's telling us in a subtle way, like the message is still not sent. It's still in progress. And it indicates us when it is being sent successfully. This is a real-world example for subtle UI with progress. Now comes the beautiful app, Tinder. I guess most of you are aware of it. Tinder is I like this feature of Tinder. What Tinder does, it shows the progress and it shows the actions live on your face abruptly. Say you send a message to your crush saying like, hey girl and something. And if the message fails, it's a very important message, right? You can't afford to leave a message or miss a message by from sending to your girl. Like, it's very important in your day-to-day life. So it just throws on your face with red colors and highlights saying your message is not delivered. Of course, even this UI is like optimistic. As soon as you send, the message goes and gets added. It doesn't show any loader or something. But when it fails, it throws the progress and it throws the error. And on clicking of the error, it gives you options, whether you can copy or delete, or you can retry sending it. Of course, all of us will just retry sending it, right? We just have to get more matches in Tinder. So these are the different types of optimistic UIs which I could find. Actually, there can be even more, but I thought this can give you a good introduction or good examples actually. Okay, now we know why we need optimistic UI, what are its advantages, what we should consider, and we have also seen some real life examples. Next is the handling errors part. There are two ways of handling errors. We have already seen the two ways in the previous examples. One is the salience way, like the user should be given a prompt visible error so he knows that something is failed. A beautiful example for this is our Tinder. When the message fails, it throws an error on the face and it tells you like your message did not pass through. Second is the casuality. This is more interesting. This is not the type which is used in Twitter. Like, Twitter doesn't care about errors at all. They don't worry like if it passes or fails. They just tells you like it. Make sure you are happy that you have liked it. Just go on with the other post. We don't care if it actually liked or not. This casuality is the type of error which is handled in Facebook Messenger. When it fails, it tells the user that it did not go through, or it's still in progress, or it failed. But it doesn't throw anything as such an abrupt error. The user can find the reason if he wants, but it's his efforts. It's not the UI's effort. These are the two ways of handling errors in case of optimistic UI. Okay, we have spoken enough about optimistic UI now. What's the next thing? What's the meetup about? It's about GraphQL. So the next thing is optimistic UI plus GraphQL. That's what we are here for, and that's what we are going to see now. Before we move on to the next slide, please forgive me. You are going to see the most shittiest flow diagrams in the world. Okay. How does a normal mutation, of course, for people who doesn't know, mutation is the process where we write or edit or delete data from a GraphQL server. And normally when we do any changes in the data, we have a tendency to refresh the data in the UI. That's how UI works. So how it normally happens is, without optimistic UI, a mutation goes as a request, the response comes. Once the mutation is successful, we refetch a query. And once the response of the query comes back, the UI gets updated. Imagine how long it will take. So it's going to be to and fro, so many to and fro process, right? This is how normally UI works. We can use actually a method called update, which comes by default in mutation, because like we know what are the things we need from mutation, right? So when a mutation goes as a request and when it succeeds, this update callback is being called, and this doesn't make another query to the server, but since it already has all the data within itself, it updates into the local store or to the local cache. In terms of Apollo, it's the Apollo cache. It updates the Apollo cache and the UI gets updated automatically. This way, we already have reduced one path and we have already improved the user experience for the user. Now, how will it look if we use optimistic UI? It looks like this. Even before the mutation request goes and reaches the server, the UI will already be updated automatically and in a positive way. And when the response comes back, only if it fails, we revert the UI or we show some error messages and we inform the user like, shit, the response has failed. So just please do it again, or like just ignore us. We are a shit product. So that is the beauty of optimistic UI. Forgive me again for the flow diagrams. Hence, this is how we are going to handle an optimistic UI. Now it's time for code and demo. I have created a dummy or like a dummy backend here. If you see here, I'm running. Okay, I forgot the count. Okay, let me start from the first. If you see here, I'm running something in my local host, and I'm running a query. 35. Okay, I'm running a query where it's going to be okay. It's a list of search history, and in the search history, I'll get the text and the ID and the type name. Just count with me. I'm counting on you people, so you count with me. 1, 2, 3, 4. It almost took 4 seconds for the response to come back. This is how I have made a delay. Like, it's not the actual time taken. I have made a delay in the dummy backend for 3 seconds. So every operation will be delayed by 3 seconds. Same goes with mutation as well. So let us try the mutation now. Count with me. 1, 2, 3, 4. It's successful at the 4th second. I pass something like text 3. Let's check our query now. 1, 2, 3, 4. I have text 3 here. Now imagine I have a application where I put in some data, I make the mutation, it goes to the server and refetches the queries. It's going to take fucking 8 seconds to just show me the update. Let me show you it in action. This is the application. Let me run it. If you see, it took almost like 3-4 seconds for me to show this list. It has 4 items now. I'm adding a new 5th item. 5th search. I'm clicking on search. 1, 2, 3, 4, 5, 6, 7, 8. On my 8th second, my history has been updated. What a beauty. And forget about the world's fastest search engine. Like, it's just for a dummy search engine. It's nowhere related to Google. I'm not pulling their legs. And it doesn't show any search results. It just updates your search history. It's just a trap. So this is the time it actually takes for the naive or the native implementation. Let me quickly take you through the code here. I guess all of you are able to see my code. If not, you just let me know. And if you want me to zoom as well, just let me know. I'll zoom it. Okay. So I have 2 components. One is my search input component. That is this piece of area where I make the mutation. And one is my read component or the query component where I just make the query and display it. How do I hide it? Yeah. Okay. Now, if you quickly have a look at my input component, I'm just making on click of the button, search button, I'm just making a mutation. And after the mutation, I'm making a refetch query. So the updated data comes back. Now let me turn this into an optimistic UI. First thing is, let me create my update function. Update is nothing but a function which gets 2 params as a default argument. One is the store or the local state. Other is the response from the mutation. That is, this update function is executed after the mutation is successful. So the response from the mutation comes as the second param for update function. Since I know my response already, okay, I just moved it, but I know it by heart. It's going to be data, and within data, I'll get my ad search. And I will have to update or I'll have to modify only if my ad search is successful, right? Ad search dot status equal to success. Okay. If it's not equal to success, then I'll just return. I'll not do anything. But if it's successful, what I'll do, first I'll get the list of local search of the local cache. So let me take it, const data equal to store dot read query of, we need to read the query which gives us the list of searches. That is nothing but my get search history query. Now with the data, I need to add my new text. So what I'm going to do, data dot search is nothing but this one, this object, this array of object. I mean, search dot push. I'm going to push a new object which will have the type name. Don't forget, when you are writing into the cache directly, type name is very important. And my type name is search. And next is my ID. Now I'm watch carefully. I'm going to give a negative number for my ID. If you watch here, every number is positive. All the ID is positive. But I'm going to give a negative number. So I will know whether this data, this particular piece of data is being updated optimistically or if it comes from the server. If it had come from the server, it will have a positive ID. And if it comes from the optimistic UA, it will have negative ID. Or I know it's a contrary, like optimistic UA and negative ID, but yeah, that's how it works. There are better ways of identifying as well. You can add a string, you can add a prefix, you can add a suffix, but I prefer this for now. Like it's just a demo. So I'll create a random number. I'll multiply it with by 1, okay, some zeros, and math dot round. Now I have my ID. Third is my text. I don't have to worry about getting text somewhere because I'm still in the same component and text is already in my local state. So I can directly access it. Now that I have taken the list of search history from my local cache, added one new object to it. Next step is write back into the cache, right? So store dot write query of, query is nothing but our get search history. And what we need to write? We need to write the data, which is nothing but our modified new updated data. This way we have written an update. But how does it much different from a normal thing? Like this update gets executed only when the mutation is successful. But already mutation is taking 3-4 fucking seconds for getting successful, right? Here comes our hero, optimistic response. What are we going to do in optimistic response? We are going to mimic or we are going to fake as if the UA or if the response is optimistic. So hence, if the response is optimistic, update function will be executed immediately and the UA will be updated immediately. So it's going to be the add search, within which I'll have status as hard-coded. I'll keep it as success because it's optimistic. And type name search. So, come on. Now I have created an optimistic response, and after optimistic response, I have created an update function to update the cache, thereby updating the store. Let's see how it works right now. Okay, let me refresh the page. It has 5 lists. Now I'm typing something new, optimistic, and watch the magic. Clicking on search, it got it added immediately, but it's in yellow color. Now after 8 seconds, it will turn white. That's how we achieve optimistic UI in our applications. So what happens here is, last time the user was not sure whether the search history got added or not. Now he can do as many as he wants and he can keep on adding. He don't have to wait for the previous one. And after everything gets added, it will get resolved automatically. Oh, there is a race condition. I just noticed. I'll refresh again. So you people don't see it. Okay. End of the day, it's just here. Okay. So this is the beauty of optimistic UA. For the user, he feels it got added automatically or immediately, but only we know that it took like 5-6 seconds for it to get added. And it's completely optional for you to whether let the user know by differentiating using colors, or just leave it without doing anything, so the user believes it got added already. That depends again on your confidence on your APIs. So this is how we achieve optimistic UI on any application, for instance. So that's it. Follow me on Twitter for more updates. And if you guys want a quality product or something, just send an email to contact@productright.com. Our website is still in building phase. We haven't completed it yet. We'll be launching it soon. And also, please do drop some suggestions and feedbacks so I can get better every time. Yeah, thank you. And any questions?
Okay.
Like, you have questions?
Yeah. Yeah, first, like, it was a really, really, really good talk. I think you might want to like stop sharing the screen. That's right.
Yeah.
And such incredible talk. I think that you has given like such a like detailed way of like explaining the optimistic response from like what is going on, like with you are refreshing the query when you're using the cast, but also when you're using optimistic response with Apollo. You should apply to work with them because it's one of the best explanations that I've seen about Apollo optimities of that. So we have a question. Yeah. So Tobias, actually, he's curious about your opinion when using like the difference between using a state and optimistic UI. So like maybe you want to use Apollo Cast, or you want to do that by yourself, right? With a use state or like a X state, like a machine or like reduce or whatever. In which cases do you rather prefer to use like the Apollo Cast, or do you want to do that like manually?
Whenever it's going to be mutation, Apollo is my only choice. Like because I don't have to do stuff manually, maintaining everything myself. If I decide to use GraphQL in application, my entire state resolves around, like my entire application resolves around GraphQL. Even for local state management, I use Apollo. So Apollo is the out-of-box solution, but not for every project I decide to use GraphQL. So when I don't use GraphQL, I do my own methods. I have reusable functions which updates the states and looks for changes. I use observables at times when I have to look for this. That's how I use it.
Oh, that sounds really good. And I totally agree with that. It's super interesting, like the new feature from the Apollo Cast in the version 3.0. So that's gonna be also like interesting. Like we might check this out in our like upcoming events. And I might have like probably the last question before we wrap it up. I would like to hear your thoughts about let's say that we are gonna have the optimities updates, right? How would you deal with kind of like if you're using, let's say that you're using Apollo and you want to invalidate cache some values, how would you like to do that, or how you are doing that in your like current projects?
Currently it's a hell, I'll say, because currently it's a huge Apollo cache is a huge chunk of objects, and mostly we try not to invalidate separate cache, and we just remove it completely, and or like we take the entire cache object, manipulate it, and put it back. We have a library called Apollo Cache Persist, which lets us manipulate cache and persist cache. We make few features of it, but I'm just waiting for the new version to be stable soon, because I have already gone through the updates of cache, like invalidating cache, emitting a part of it, garbage collection. Everything is super cool with it, and it will definitely remove huge chunk of codes from our code base, like the custom code which we have written, the pain in the hash we have, everything will be taken off.
That sounds good. I totally agree with that. So yeah, perfect. So I think we can wrap it up. So like first, like thanks so much for joining us today, for giving this incredible talk. We have a lot of proposals, but you reached us out like long time ago. So I said, Vilva has to be here, the first one. And so yeah, thanks so much for like coming here and just like joining and like share your knowledge. So I really hope to see you sometime soon.
Yeah, sure, Carlos. Maybe after all this lockdown shit gets over, we should meet somewhere.
Yeah, yeah, that'll be great. So I think like we are gonna like jump into kind of like